We're going to start a discussion of our 4-channel system here and go through the same control process we just went through with pneumatic. In our hydraulic system, we have our 4 channels. We're looking at the isolation valve, also known as the inlet valve. It's going to stay open for normal operation until it's energized to isolate the pressure to a specific brake, just like we did with the trucks with air pressure. Now let's talk about why we have this solenoid normally open. Normal operation has brake pressure applied to the brakes. Now this is also the fail-safe mode if something goes wrong. What we're saying here is if something happens and we lose power to our solenoids, we blow a fuse, it's going to fail open so that we have normal brake pressure applied to the brakes. When we have proper operation, the normal pressure has to be blocked before the ABS system can modify brake pressure to a specific wheel or axle. This is referred to as the hold or block mode, like we just went through with the pneumatic system. Now we can reduce pressure by opening the dump valve, but only after the wheel or axle is isolated by the blocking valve that's now closed. So we've got this system. Let's have a look at it. Doesn't matter if it's air or hydraulics. They're going to perform the same function. They can use different components to control them, but when a wheel starts slipping, like you see at speed at the top, at the bottom, we're going to show what's happening to brake pressure. In the middle, 3 states of our system. Normal pressure, increased pressure, whichever way you want to look at it, hold pressure, and reduce pressure. Let's walk down through here and look at this. We're going to be turning hold, reduce. Notice the first stage is always hold pressure, then reduce it. Go back to hold, go back to normal, go back to hold and normal several times, come back up and reduce pressure, and then go back to hold. So we're going to see action like this taking place as we stop on uneven surfaces or slightly low friction surfaces. This is the scenario. This is how we tie wheel speed, brake pressure, and solenoids all together. Graph these 3 PIDs with your scan tool, and you can observe this action. You can monitor it on some real live vehicles and find out how it works. Now, heavy trucks had an air pump to make up for the air lost during the pressure reduction phase. Cars and light trucks need an electric pump to make up for the lost fluid when the brake pressure is reduced. And we're going to go through the cycling of all these valves on a typical 4-channel ABS so that we can see how they work on modern passenger cars and trucks. Because remember, this is what we're going to use for ABS and stability control, traction control, and all those other wonderful features. We have 2 sides of the diagram, 4 legs. They're all going to function the same. In this particular example, just for convenience, we're going to look at controlling the brakes and the right rear in this example. So we're going to focus on these. We have a dump valve here. It's normally closed. Now we've already said we're going to have to do some various things. We've talked about the isolation valve. Let's see how this has to work. Again, we got here, just like we did with the trucks. We have a slip. We need to adjust the right rear. It's turning too slow. It's indicating slip. In this case, the hydraulic pressure must be lowered. So first step, isolate it. We close the isolation valve. Notice we have bright orange coming up the isolation valve, then it turns to yellow. The right rear channel is now isolated. This is the same step we took with the air pressure system, just a little more complicated. Now, if we need to reduce pressure, we're going to activate the normally closed reduction solenoid and open it slightly and let pressure come out and be stored over in the accumulator. The next step is to go back, turn this off, keep it isolated. If wheel speed looks like it's returned to normal, open the isolation solenoid. If wheel speed is still too slow, and reduce the pressure even further. So the PCM makes this decision. Do I stay in this pressure? Do I reduce this pressure? Or do I increase this pressure back to normal? Here's what happened in our scan data. We're showing you this. Slip was detected. We went to the hold mode. It's lower than the rest of them. So we isolate it and we hold it. Then we reduce the pressure to bring the speed up, and now it's catching up to the speed of the others. Why we went back to this chart again now is we've gone from my slip through the hold, through the pressure reduction. We wanted you to see the total picture of identify the slip, go to hold, go to pressure reduction. So this is the process we went through. Brake fluid was allowed to go to the accumulator to reduce brake pressure. Now the pump needs to be run to replace the fluid to resume normal braking activity. Fluid flows to the accumulator, and then we replace the fluid that's lost to reduce the pressure. The pump you see highlighted in red here is pulling fluid that has been stored in the accumulator back up and putting it back into the system so that we don't have any loss of fluid. And when we open the holding solenoid and go back to normal, everything will be fine. So we've gone through, we've isolated it, we've opened the reduction valve, we've reduced the pressure, we've taken the fluid that was used to reduce the pressure, recycled it with our pump so that the system is now back to normal. The pump is in this, the accumulator is in here. So what you have here is a very expensive piece. We need to go through and make sure we diagnose this pricey piece accurately so we make a good diagnosis.